There's a famous question in quantum theory. If you take a cat and you put it in a box, and you are an awful human being who also put some kind of dangerous chemical that might decay quantum mechanically in that box, before you look in this box, how should you think about the state of the cat? And quantum theory famously suggests that the state of the cat, in fact, the state of the entire environment in the box, should be thought of not as definitely the cat's living, the pill is unbroken, and so on, or the cat is dead and the gas, has been released. But instead, you should have what's called a superposition, which is very hard to understand intuitively. Maybe it's impossible to understand intuitively. And so, this is the famous Schrodinger cat paradox. So there's, the dead cat plus the happy living cat. So how do you think about these sorts of things? There are other kinds of paradoxes having to do with the phenomena of quantum entanglement, not paradoxes, but conceptual difficulties, let's say. And there are many approaches to trying to understand what is quantum theory saying about the universe at its core. What's the picture it's painting? And so I'm interested in studying both certain specific interpretations of quantum physics. And when I say this, it's not like just writing long-winded essays about them. There are actual calculations one can do. There's actual checks, mathematically that you can make to see that things are consistent. So interpretations of quantum physics, so certain specific interpretations, as well as kind of overall approaches for testing. Like if someone comes to you with, I've got an interpretation, what kind of obstacle course does this interpretation need to run through in order to pass muster with what we currently know? So there's that, and there's the linkages between this area and the very exciting areas of quantum information, quantum computation that I'm presently teaching class in. So these are very, very broadly speaking my areas of interest and my areas of current work.